Hello everyone, you're welcome once more to today's class with Ojo Hygienist. Today we are going to be looking at a new topic, number-based system. We're going to take it gradually and solve series of questions under the topic number-based. Stay tuned and enjoy the class. In number-based system, there are several rules and classifications of number base, but we are going to lay our emphasis and interest on the ones that concern us and the ones that we are good at. This is going to help us at secondary school level for SXC, for JAMB and other exams at O level. We know we have decimal numbers, we have binary numbers, we have octal numbers, we have hexadecimal numbers, we have ternary numbers, and so on and so forth. But our emphasis is going to be on the decimal numbers and binary numbers. Decimal numbers and binary numbers. Although we are also going to touch a bit other number-based system aside these two, but what we are going to have at the back of our mind is that most of the questions and most of the things we ought to know at this level is how to solve mathematics either in decimal or in binary, how to convert from base 10 to other number bases, and how to convert from other number bases to base 10, how to multiply numbers in different bases, how to divide, add and subtract numbers in different bases. That will be our emphasis, not on their names, not on the type of numbers base system we have. But one thing very significant we have to know is that a number-based system contains digits that cannot be equal to that number base. It cannot be equal to or greater than the number base. It must be one less than the number base. So what I mean by that is that if we have a number in base 2 that we call binary number, the possible digits that exist in number in base 2 is 0 and 1. You cannot have up to 2 or greater than 2. In base 3, we have numbers that are contained in base 3 are 0, 1 and 2. Base 4, we have numbers ranging from 0 to 3, 0, 1, 2 and 3. In base 5, we have 0, 1, 2, 3 and 4. In base 6, we have 0, 1, 2, 3, 4 and 5. In base 7, we have 0, 1, 2, 3, 4, 5 and 6. In base 8, we have 0, 1, 2, 3, 4, 5, 6 and 7. In base 9, we have 0, 1, 2, 3, 4, 5, 6, 7 and 8. Then in base 10, we have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We are going to stop here. Like I said, we have other number bases, base 11, base 12 and so on and so forth, but we are going to stop at this point. We are going to lower our emphasis from base 1 to base 10. If there is need to solve questions under other bases, there are the same rules that guide base 1 to 10 will still be applicable, and so we will not have much trouble. So let us see how it works. So first of all, we'll look at binary system or binary number. As the case may be, binary system of number is also called numbers in base 2. So this number is very important to be discussed because it has application even in computer application, in digital system. It is number that deals with zeros and one. So like we had, or like what I said initially, that the numbers that exist in base 2 are going to be numbers less than 2, which we have only 0 and 1 as numbers in base 2. So you cannot have anything beyond 0 and 1 in base 2. That is what we are saying. So if we compare it with numbers in base 10, let's just give a simple rundown of this, even though we are going to explain how we got that. If we have a numbers in base 10 and the set of numbers also in base 2, what we are saying is that we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, and then 10. These numbers in base 2 can be represented first. 0 in base 10 is still 0 in base 2. 1 in base 10 is still 1 in base 2. But 2 in base 10 is 1, 0 in base 2. 3 in base 10 is 1, 1 in base 2, because you cannot have more than 1 in base 2. 4 in base 10 is 1, 0, 0 in base 2. 5 in base 10 is 1, 0, 1 in base 2. 6 in base 10 is 1, 1, 0 in base 2. 7 in base 10 is 1, 1, 1 in base 2. 8 in base 10 is 1, 0, 0, 0 in base 2. 9 in base 10 is 1, 0, 0, 1 in base 2. 10 in base 10 is 1, 0, 1, 0 in base 2. Like I said, we are going to see how we're able to arrive at these numbers in base 2. So this is just what we refer to as binary numbers in base 2. So it contains only zeros and ones as its digit. The highest digit should be, so it means that the higher digits of a certain base should be one less than the base number under consideration. That is what we are saying. It must be one less than the base number under consideration. So we look at conversion of number bases. What do we mean by conversion of number bases? Conversion of number bases simply means changing one number base to another. You can change from base 10 to base 2 to base 3 and so on and so forth. But the basic process of doing this conversion involves the conversion of numbers from base 10 to any other base, or from any other base to base 10. That means that base 10 is the standard. But we can also do conversion between bases other than base 10. But base 10 is taken as the standard. That's why it is very easy to convert from other bases to base 10, or from base 10 to other bases. So we're going to look at it gradually, starting with conversion from base 10 to any other base. So to do that, what we will simply do is to successively divide the number in base 10 by the required base. Okay, now let's look at few examples to convert from one base to base 10. So if we are asked to convert 273 base 10 to base 4, what we will do, I said that you are going to divide the number in base 10 by the required base. So since the required base is base 4, we're going to divide 273 by 4. We're going to divide it successively until we get 0, until no number is remaining. So if you divide 273 by 4, you are going to have 68 remainder 1. Divide 68 by 4, you will have 17 remainder 0, because if you divide 68 by 4, you get 17, there will be no remainder, so the remainder is 0. You have 4 divide 17, you have 4 remainder 1. 4 divide 4, you have 1, there will be no remainder, so 0. Then 4 divide 1. Since 1 is less than 4, you will write 0, and this 1, you write it as the remainder. Then you read or write from the bottom to the top. So this is going to be equals to 10101. In what base? The base that is required, that is base 4FOUR. It is advisable to write the base of numbers in words. The reason being that sometimes our handwriting is not legible enough for the examiner to understand. What I mean is that if you write 101014, it is acceptable, but the problem is that some people might not be able to understand that. Some people might write it this way, 10101, for probably that the way they write, and then the examiner will not understand that this is subscript. But even if you write 10101 and then the 4 you write it in words, even not as a subscript, the examiner can actually see this as a base. So it is better to write in words than in numbers, but always know that the base is a subscript so that you'll be on the safe side. So we are going to look at one more question in converting from other bases to base 10, because it's the same process. Any other base to base 10 is the same process. So if you are asked to convert 437 base 10 to base 5, what do? We draw the same line. 437 divided by the required base 5. If you divide 437 by 5, you are going to get 87, and you have 2 remaining. If you divide 87 by 5, you are going to get 17, and you will have 2 remaining. You divide 17 by 5, you are going to get 3, and you have 2 remaining. Divide 3 by 5. Since 3 is less than 5, you now write 0 and write the 3 as remainder. At this point, we stop and read from the bottom to the top. So we have 3, 2, 2, 2 in base FIVE5. So we have been able to convert 437. So the number 437 in base 10 is equivalent to 3222 in base 5. You can see that all the digits here, none is equal to or greater than 5 because the base is 5. Let's now look at conversion from other bases to base 10. In conversion from other bases to base 10 is like the converse of what we did in converting from base 10 to other bases. In this one, it involves the process of successive multiplication, not like the other, which is successive division. So let us look at that. We have 2 possible methods we can use in doing that. There are so many methods anyway, but I'll give you these 2 basics. Let us look at the first method. If you have, for example, if you're asked to convert 110101 base 2 to base 10. Yes, to base 10. Let us how we are going to do that. The first thing we will do is to write the number 110101 base 2 and assign place values to these numbers from right to left, starting with 0. So I assign place value 0 here, 1 here, 2 here, 3 here, 4 here, and 5 here. I repeat, from right to left, starting with 0, 0, 1, 2, 3, 4, 5. We are going to see what these numbers represent. Now, what do? In order to convert that, we start from here. We pick this number 1 that is written here, we write it, times the base that it originally has, 2. Then raise to power the place value you have assigned, 5. This is for this. Then plus, you pick the second digit, which is 1, times the base 2, raised to power the place value 4 given to it. That's how you take it gradually. Plus the next digit is 0. 0 times the base 2 raised to power the place value of that 0, 3. We continue, plus The next value is what? 1. 1 times the base, which is 2, raised to power the value assigned to it 2, plus the next value is 0. 0 times the base raised to power the value attached to it 1. The next value is 1, so it is 1 times the base raised to power the value place value attached to it 0, and we have been able to expand this number in this form. So this is equals to 2 raised to power 5. We are going to find it so that we have 1 times 32, because 2 raised to power 5 is 32, plus 1 times 2 raised to power 4 is 16, and we have that one as well. We also have plus the next one is 2 raised to power 3, whatever it is, times 0. Okay, let us just write it. 0 times 2 raised to power 3 is 8. You put it that way. The next one is this one, which is 1. 2 raised to power 2 is 4. You put it. Then plus the next one here is 0 times 2 raised to power 1 is still 2. Then the final one is 1 times 2 raised to power 0 is 1, because any number raised to power 0 apart from 0 is 1. So if we do that, this is equal to 32 times 1 is 32. 16 times 1 is 16. 0 times 8 is 0. Of course, any number time multiplied by 0 is 0. Plus 1 times 4 is 4. Plus 2 times 0 is 0. Plus 1 times 1 is 1. So when you sum these numbers, we are going to get 53 then in base 10. It therefore implies that the number 110101 base 2 is equals to 53 in base 10. This is how you convert from other number bases to base 10. This is how you convert from other number bases to base 10. Let me solve one more question using the same method. If I am asked to change 625 base 7 to base 10, I do the same thing. I am going to say 625 base 7. I will assign place values to them starting from the right to the left with the digits 0 as the first, 1 and 2. Then what do? I say you pick the first digit from the left, 6, times the number base, which is what? 7, raised to power the place value, that is 2. Again, plus the next digit is 2 times the base, which is 7, raised to power the place value, that is 1, plus the next digit is 5 times the base, which is 7, raised to power the value assigned to it, that is 0. If we simplify further, we have what? 6 times 7 squared is 49. Then plus 2 times 7 raised to power 1 is 7, plus again 5 times 7 raised to power 0 is 1. Remember I said that any number raised to power 0 is 1. So that is what we have. So if we simplify further, 6 times 49 will give us 294. 2 times 7 will give us 14, and 5 times 1 will give us 5. So that if you add 294 to 14 and to 5, you have 313 in base 10. It therefore implies that 625 base 7 is equals to 313 base 10. This is the first method used in solving, converting from other number base to base 10. Or you can decide to use what we call successive method. You can decide to use what we call successive multiplication method. Okay, so let's look at those two questions we just solved now. Let's resolve it using successive multiplication method. If you are asked to convert 110101 base 2 to base 10, If you want to use successive multiplication method, this is what you are going to do. Write the digits 110101 base 2 to be equals to, what you will do is now multiply them one after the other. The first digit, which is 1 here, times the base, which is 2. If you do that, you will have 2. That is 2. Then you successively add the next digits to it. If I add the next digit to it, 1, I'm going to get what? I'm going to get 3. Then multiply it again by the base, which is 2, and that will give me 6. I'll add the next digit to it, which is 0, and that will still be 6. Multiply it again by the base, and that will give me 12. And I will add the next digit to it. I'll add the next digit to it, which is 1, and that will give me 13. Multiply it again by the base 2 to get what? To have 26. And when you have 26, you add again the next digit, which is 0. If I add 0 again, I will have 26. Multiply it again by the base, which is 2, to have 52. I'll add the next digit to it, which that is 1, and that will give me 53 base 10. And we have used the method of successive multiplication. But I prefer the first method. And I hope you also prefer that. It is easier. Let me not confuse our minds. So let's just adopt this first method. Maybe in a subsequent video, I'll explain the second method, successive multiplication, very well. So go through it, give yourself some questions, solve, and if you encounter a problem, we'll look at it. Put your problems in the comment section. Probably we will treat it in our next video. Thank you for watching, and God bless you.